Hello students, how are you? In the previous video, we had talked that square root 2 is an irrational number. Are you comfortable with that proof now? Did you try to do it in your notebook? Did you understand the concept? If you had any doubts in that, let's see theorem 1.4 square root 3 is an irrational number. Both the proofs are very similar. The proofs are being dealt separately because it will help you understand it better. Isn't it? So let's start. How did we do the proof in the previous video? It was a proof by contradiction. In contradiction, we assumed that the opposite of the given statement is true. We made an assumption that the opposite of the given statement is true. What is the opposite of the given statement? That will be, let us assume that square root 3 is rational. That is our assumption. We have assumed that square root 3 is a rational number. Now we'll do some calculations and arrive at a contradiction. We arrive at a contradiction means that our assumption is wrong. What is our assumption? Our assumption is only this, that square root 3 is rational, which assumption will turn out to be wrong. Hence we will say that square root 2 is irrational. Okay. So when square root 3 is rational, then we can write square root 3 is equal to a divided by b. Isn't it? Where a and b are co-prime. A and b are co-prime. Means there is nothing in common in a and b which can be cancelled out. Now square both sides. What do you get? 3 is equal to a square divided by b square. This implies 3 times b square is equal to a square. This is our statement, equation number 1. Very simple. We have done nothing special over here. Now from the theorem 1.2 that we discussed few videos back, we know that 3 is a factor of a square. Therefore 3 is a factor of a also. A. So we can write a is equal to 3 times c. Substitute 2 in 1. What do we get? Value of a we have to write as 3c. That means 3b square is equal to 3c square of that. That will be equal to 9c square. And then when you cancel out 3, you get b square is equal to 3c square. Again, what we get? 3 is a factor of b square. Also, 3 is a factor of b. This means 3 is a factor of, see, 3 is a factor of a came here, 3 is a factor of b came here. So 3 is a factor of both a and b, which is a contradiction. This is a contradiction. Hence our assumption is wrong, which means square root 3 is irrational. Okay? Was it simple or difficult? See the flow of the proof once again. What we do? We assume that the opposite is true. That means we assume that square root 3 is rational. When square root 3 is rational, we write square root 3 in the form a by b, the general form of a rational number, where a and b are co-prime. We have cancelled out everything that was common and we have got two prime numbers a and b. Then we square both the sides to get 3 is equal to a square divided by b square. This gives us 3b square is equal to a square. From there, we get 3 is a factor of a. So we write a as 3 times some other number. Substitute for 2 equation 2, so this in 1. Substitute equation number 2 in equation number 1. Here then you get 3b square is equal to 3c square, that is equal to 9c square. This gives us b square is equal to 3c square. Again, 3 is a factor of b square, that gives 3 is a factor of b, which gives us 3 is a factor of both a and b, which is a contradiction. We have arrived at a contradiction, means our assumption is wrong. Our assumption is wrong. Square root 3 is irrational. Okay. Okay. While watching the video, you might feel that it is very simple, and then after a few days you tend to forget it. So practice. This is a very tricky proof, and you need a practice. And the interesting part of this proof is it comes in the exam almost every year. There are 3-4 similar proofs like this. It comes in the exam every year. Now that I have talked of square root 2 and square root 3, you can always prove square root 5 is irrational in the same way. Or square root 7 is irrational in the same way. Isn't it? So, maybe square root 11 is also an irrational number. You can talk of all such numbers. Okay. Shall we move forward now? Now, we already know that. What do we know? The sum or difference of rational and irrational number is irrational. Sum and difference of rational and irrational number is irrational. And we also know product and quotient of non-rational and irrational number are irrational. What does that mean? Square root 2 plus 2 is irrational. Square root 2 minus 3 is irrational. Or you can say 2 times square root 3 is irrational. All numbers like this. Square root 3 divided by 2 is irrational. Square root 3 divided by 3 is irrational. We have seen all these things in the previous class, standard 9th. Previous class means standard 9th here. So we will prove these things in this video now. Okay. So let's come to the next proof. So that square root 5 minus square root 3 is irrational. Again we will prove it by contradiction. We will assume let 5 minus square root 3 is rational. So we can write it as 5 minus square root 3 is equal to a divided by b, where a and b are co-prime. There is nothing common in between a and b. Okay. So what we can write? 5 minus a divided by b is equal to square root 3, isn't it? So we can also write square root 3 is equal to 5 minus a divided by b. That is equal to 5b minus a divided by b. So see the RHS now. Numerator 5b minus a. Is it rational or irrational? This is rational because a and b both are integers and they are co-prime also. If you talk about the denominator, b is also an integer, so b is also rational. So RHS is rational. RHS is rational. RHS is rational means LHS must also be rational. Which cannot be true. We already know that square root 3 is irrational. Hence we have a contradiction. That means 5 minus square root 3 has to be irrational. Did you see the proof? How simple it was as compared to the previous one? See, we have assumed that 5 minus square root 3 is rational. Now we have assumed it to be rational. Then we can write 5 minus square root 3 in the form a divided by b, where a and b are co-prime. Co-prime means integers also. That means 5 minus a divided by b is equal to square root 3. Very simple. Now let us simplify it. Square root 3 is equal to 5 minus a by b. Let's take the LCM. Numerator will be 5b minus a, denominator will be b. Isn't it? LCM is b, so numerator becomes 5b minus a. Now here numerator is now rational. In fact, numerator and denominator both are integers. Numerator and denominator, both of them are integers. So RHS has to be irrational now. This number has to be rational. It cannot be anything else. Now when this is rational, this also has to be rational if our assumption is true. If our assumption is true that 5 minus square root 3 is rational, then square root 3 also has to be rational. But we already know that square root 2 is irrational. So we arrive at a contradiction. Therefore, square root 5 minus square root 3 has to be rational. Okay. Shall we see one more example now? Example is 3 times square root 2. We have to prove that 3 times square root is rational. So again we assume it to be true. Let this to be rational. Okay. See, all the proof in this chapter, whether the number is rational or irrational, have to be done by which method? Contradiction method. Contradiction method. And in this method, you have to assume that a given statement, whatever you have to prove, you have to assume that that is false. And when you assume it to be false, the opposite has to be true. Given number is irrational. You have to prove that a given number is irrational. Assume that the number is not irrational, number is rational, and then do some calculations to arrive at a contradiction. Once the contradiction is arrived, that means our assumption is wrong. Whatever we have assumed, calculation cannot be wrong, assumption can be wrong. So assumption is wrong. If the assumption is wrong, the number turns out to be rational. Okay. So again we can write 3 into square root 2 to be equal to a divided by b, where a and b are integers and they are both prime, isn't it? Now let square root 2 remain on the left hand side, let 3 go to the right hand side, a divided by 3b. Again we have RHS is rational, which implies this implies LHS is rational, which is a contradiction. Which is a contradiction. So 3 square root 2 is, what is it? Irrational, isn't it? We have proved the number to be irrational. So in the exams you may get any number wherein sum or difference of a rational and irrational number or the product of rational and irrational number is asked to be proved to be true. See, rational, there is one rational number and one irrational number. Okay, one rational, one irrational number. Now take the sum of these two, difference of these two, product of these two, or division of these two. Do any of these operations, the result has to be irrational. And in the exam, you can get any number. Rational number can be anything like 2, 3, 4, 5, 6, any number like this. Irrational number can be anything like square root 2, square root 3, square root 5, square root 7, square root 11. Not more than that. Generally, you get irrational numbers till this only. So all these irrational numbers may be added, subtracted, multiplied, or divided by another rational numbers, which can be any number one. You have to prove that the result is irrational. How will you prove? Just assume that the numbers are rational. That means, let's say rational number, let's say I take it to be A, not A. Let's say rational number I take it to be R, irrational number to be capital R. So R plus, minus, multiply, divide, whatever, square root of R. This is to be rational and take it to be equal to A divided by B, and get the irrational number on one side, rational number on all the irrational number, this square root R. Just this should remain on one side and other numbers will go to the other side. Okay. After that, you will see one side is rational, one side is irrational. Once you are at that position, you are able to say that LHS is not equal to RHS, and this confusion has arisen because of the assumption. What was the assumption? That the number is rational. Okay. So in the coming video, I'll discuss the exercise 1.3 of the NCERT textbook and just try these questions. One of these questions will be there in the board examination. There is no escaping the fact. Any one of these questions has to be in the board examination. So it's very important to learn these questions. Try these questions. I have already discussed it. You can try it before I start it in the video. Okay. See you in the next video. Thank you.